Hello 11th standard warriors. Welcome to the Nurture series. In our previous class, we have talked about what is momentum, and that's nothing but a vector quantity which is in the direction of the velocity, and it's the effect of the mass and velocity. Today, we are going to see what is the conservation of momentum principle and how you can solve problems which you could not solve earlier. Not just that, we are going to see variety of questions where you will have to use concepts apart from the conservation of momentum, and we'll also see the applications of center of mass today. All of this with me, Shreyas, your physics master teacher, your capto for this channel. Welcome aboard. Hello my minion, hello Kirtik, good evening, hi Suchi. Hello Ishpreet, hello Anil, hello Harita, welcome aboard Danish, and I hope you guys are all excited for today's session. And if you are new to this channel, first of all, let me tell you, welcome to JEE Enthuse. This is a dedicated channel for all the students preparing for exams like JEE, KVPY, BIDSAT, and sometime more than a decade. So don't go by my looks. So I have been teaching like for a very long time, and not just that, many of my students have cracked IIT with really great ranks. Many of my students have got 2-digit all India ranks, and many of my students have aced the IIT JEE Advanced, Mains, and even the medical entrance test. So I really hope this channel brings in lot of joy, it brings in lot of learnings, and it also inspires you to study more. So if you already are enjoying the video, do not forget to smash the like button as a small Guru Dakshina, and if you have not yet subscribed to our channel, do not forget to hit the subscribe button out there. Hello Ankit, nice to see you. Hello Payal, hello Vikram. Saja, I'm very good bacha. Hi Kalash, hi Chandan, good evening. Yes Kirtik, I don't want to talk about cricket too much because I know we had a very bad match out there, but there is one thing that I would like to tell you. See, that's what you should learn from India-Pakistan match. We might lose, we might win. That's a part and parcel of the game. So the same thing also applies to you. When you don't get a problem or when you fail in one test, does not mean you give up hope and you stop preparing for the exam. See, just because India lost one match does not mean we are not going to play the next match. Does not mean we are going to quit watching cricket. Does not mean, all the players are going to quit cricket and going to play some other game. So they are going to continue, they are going to improvise, they are going to learn from the mistakes. So that's the same thing which also applies to you. So make sure that you take all these learnings in your studies as well. So let's talk about what is conservation of momentum. But before that, you might have definitely heard about this example, which is pretty much standard even in your 9th standard. And you might have heard about how when a cannon fires a ball by Newton's third law, or when you throw a ball by Newton's third law, you get a push behind, that's the reaction force. So for every action there is a reaction force, and that's what helps us probably understand the conservation of momentum principle. See, this entire system was at rest before the ball was fired. That's right. Yep, that's Newton's third law, correcto. And that's a recoil. The entire system was at rest. So the total momentum of the system was 0. Agreed? So the total momentum of the system was 0 before firing. The moment you fire, what happens? The ball gets a momentum towards your right side. Correct? The ball gets a momentum towards your right side. But the cannon, the entire firing thing gets a momentum towards your left side. So one momentum is to the right, the other momentum is towards the left. So what happens? Both these momentums, remember they are vector quantities, they will cancel each other, and you will still see the total momentum of the system is still 0. So this momentum towards the right, this momentum towards the left will cancel, and it preserves the momentum. So you might be wondering, why is momentum preserved? Well, the simple answer to that is by Newton's laws. If the total force acting on it is 0, if the net force externally acting on it is 0, then the momentum should be preserved. So no matter what happens inside the system, it might burst, it might apply some force, there might be some chemical reaction. It's all internal. It's a part of the system. These internal forces have no role to play. What it says is, if outside there is no force, there is nothing which is changing the system from outside, there is no external force, then the total momentum of the system will be conserved. So the total momentum before was 0. After the explosion, after the firing, the total momentum is still 0. Makes sense, my warriors? Welcome aboard. Hello, the new warriors. Welcome, welcome, welcome. Yes, this is the second class of collisions. Center of mass was covered in one class. I had taken a marathon session on center of mass. Center of mass is over. Now, this is the other chapter. It's related to center of mass. But yes, this is the second lecture of collisions, momentum, impulse. Okay, so what is the conservation of momentum principle? It says that when you take an isolated system, what is the meaning of an isolated system? Isolated system means, there is no external force acting on it. Okay? So an isolated system just means that the external force, the net external force is 0. So the total external force is 0. Then the total momentum remains conserved unless and until you apply some external force, obviously. Yeah. And this also follows from Newton's laws. You can see whenever there is force, it creates change in momentum. We all know that. So force creates change in momentum. So when there is no force, obviously there is no change in momentum. Makes sense. Alright. Now, there are other things which you need to keep in mind. Tell me one thing. When this explosion occurs and this ball comes outside and the cannon recoils, is total energy before, the mechanical energy before and after the same? Let me know in the chat box. What do you think about the energy, my warriors? Is the energy before and after the same or different in this problem? Come on, think about it. Think about it. Nice to know, NEET Angie aspirant. You came to my HC Verma class yesterday. I hope you enjoyed it too. Hi Lakshmi, welcome aboard. Yep. So same says Hemant, Anha says no, Harita says same, Chandan says same, Roshni also, Roshni says different. Well, maybe same says my minion. Well, the correct answer is, think about it, during that explosion, there was some chemical energy which got converted into kinetic energy. Think, before the explosion, before the firing, what was the system doing? It was at rest. That means there was no kinetic energy. Now that explosion happened. What is that explosion? Chemical energy getting converted into the kinetic energy of the ball and the cannon. So where did this kinetic energy come from? It came from the chemical energy. So yeah, the total energy is conserved. The total energy of the universe is conserved, no doubt about it. But I asked you mechanical energy. Mechanical is only the sum of potential and kinetic energy. So where did the kinetic energy come from? It came from the chemical energy. Energy, mechanical energy may not be conserved every time. So that's a very important point for all of you. So I hope you're going to note it down. Even when momentum is conserved, the mechanical energy may or may not be conserved. Keep this in mind. Okay, so mechanical energy will be conserved only in certain cases. I have talked about mechanical energy conservation in my previous chapter, work power energy. Okay, so mechanical energy is conserved only when there is no non-conservative force which is doing work. Okay, no non-conservative force is doing work. So only then mechanical energy is conserved. Means friction, air resistance, normal, all these kind of forces should not do any work. Only then you will see the mechanical energy is conserved. Yeah, correcto. I hope this is clear. The modern man, you can leave a comment after the session is over. I'll definitely end up replying to you. The next thing is that internal forces do not affect the total momentum of the system, which is quite obvious. See, the force which was applied on the ball was internal. The force which was applied on the cannon is internal. You cannot change the momentum from within. It has to come from outside. Like I cannot push myself. I cannot say I'll push myself and I'll start moving. Or you cannot sit inside a car and push the car. You have to go outside and then only push the car. So only external forces can change the momentum. Internal forces will not affect the total momentum of the system. One last thing before we go ahead, and that is, how do you calculate the total momentum? Remember, the total momentum of a system just simply means, okay, so what is the total momentum of a system actually means? It's momentum of 1 plus momentum of object 2 plus momentum of object 3. So there could be n objects. So momentum of 1, 2, 3, 4, all those n objects momentum added. This total momentum is also the momentum of the center of mass. I had given you this rule in the center of mass class, but still I am giving it to you over here just in case you have forgotten, because there will be problems on this. And the meaning of the momentum of center of mass is nothing but the total mass into the velocity of the center of mass. That's what it means. Okay, so P1 plus P2 plus P3 is nothing but the total momentum, which is nothing but total mass into velocity of their center of mass. I hope that is very clear. Okay, what is the difference between linear momentum and momentum? So linear momentum is just momentum. Generally, whenever I refer to the word momentum, I am often referring to the word linear momentum, because in rotation you are going to see angular momentum. In these cases, these objects are translating, so the momentum of translation is called as linear momentum, or just simply put, momentum. Okay, just like you have velocity and angular velocity. So whenever I say velocity, it just means linear velocity. Angular is specific to rotation. Okay, now when you are solving problems, use these tricks which I am giving it to you. First thing is, always draw the diagram before and after. You are going to see a lot of problems where things are going to collide, or things are going to jump onto each other, or probably one system is there and it exploded. So you are always going to see some situation before and after. So always draw those things and show all the important data like velocity, acceleration, force, angles, etc., whatever you think will be needed. Second thing, because generally the questions will involve collisions or momentum conservation, make sure that you use the principle, and obviously this can be only applied if the net external force is 0. So you will apply momentum conservation principle, that initial momentum is so much, final momentum is so much, so hence they should be equal, and then you will try to solve the problem. If you think that you are not able to understand, don't worry, we are going to solve questions, you will get a hang of these. Next thing, remember, if all the things are not along a straight line, like over here, one velocity is here, one velocity is here, another velocity is here, make sure you choose some coordinate axis, x-axis, y-axis, and then what you do, split the vectors. So make sure you split the vectors by resolving it along the axis, the relevant axis. Next thing that you need to do, if you still see that there are many variables, still you see that there are few equations and you cannot get all the unknowns, then you have to use more equations. Where will you get the more equations from? You will get it from either energy conservation or some other information about forces, or maybe even kinematic equations which will be used. So all your previous knowledge from the 11th standard will be useful in these kind of questions, either kinematics, Newton's laws, I don't know, it could be anything. Alright, I hope that makes sense. So for solving the questions, make use of all the previous knowledge that you have studied, and let's start with the questions. But before that, it's a good time that we congratulate and give a big shout out to all our rank holders and all the students who have made Vedantu and you guys really proud. In fact, you should be very, very thrilled to know about your seniors, that more than 1,500 of your seniors, 1,500 plus Vedans have cracked the JEE Advanced examination just from Vedantu alone. And these stories are amazing. I mean, you might think that this is a big number and fine, it's okay, but let me tell you, each rank, each number is a story in itself, because these students have grown from nothing to really becoming a hero for all of you. Students who got more than thousands of rank have improved their rank to probably 3-digit or even 2-digit ranks from nothing. So it's all because of the power of Vedantu and our classes. And if you are feeling really proud about this, do not forget to smash the like button. And if you want to prepare for the upcoming term examination, there is a crash course just for you for a very affordable price of 2,700 rupees. This will take care of your term 1 assignments, different kinds of questions like assertion, reason, and your case studies, single choice questions, all the chapters completed. So make sure you join the crash course for CBSE Term 1 in the link which is there in the description below. It's there for 11th, it's there for 12th, and it's also there as a part of the JEE course. So if you take the JEE course, you will automatically get all these benefits. So check this out in the description box below. Okay, let's go ahead with our first question. And here we have two particles of mass m and 2m, and they are traveling along the x-axis on a smooth surface with speeds u1 and u2. They collide. After that, their velocities become v1 and v2. What do you think is the ratio of the velocities of their center of mass before and after the impact? Interesting question. Oh yes, Anil, I am so glad that we have now become a 75 plus K plus family. Thank you, Saja. Hello, Siona Art and Vlogs. Welcome aboard. Yep. So I'm really thankful to all of you for making our family grow really big. Thank you so much. How much time should you study after the class? Imani, I think easily 5 to 6 hours. Yeah, on an average. Okay. We'll be getting one-shot videos for all chapters. Imani, yes, you'll be getting, but that is after completing the chapters, not before. Because one shot is not good for health, your mental health before. So that's why you would have seen all my one-shots are after completing the chapter, not before completing the chapter. Okay. Thank you, Chandan. Thank you. Oh, AMS, you are too from Pune. आमची पुणे घेऊन ये सगळ्यांना सगळे पूर्ण जनताला घेऊन ये. All right, AMS, thank you. Will I revise gravitation? Yes, Nandini, I'm planning to revise gravity, in fact, this week itself. Okay, 1:1. Very good, my warriors. Excelente, excelente. So guys, the correct answer is 1:1, and the reason for that is, before, whatever particles are there, the total momentum of the system, remember, will be the momentum of the center of mass. So now, whether it is before or whether it is after, the total momentum is same, correct? In the collision, the total momentum is conserved. So hence, the momentum of the center of mass will be also conserved. Hence, before and after is same. So hence, 1:1. Correcto. Excelente. Excelente. Yes, the answer is C. So this was a warm-up question. Here comes the next question coming up on your screen. Very good, Anna. Very good, Saja. Very good, Harita. Nandini. Very good. All right. Chalo, let's see. Two particles have, which are A and B, have, no velocity initially. They are at rest. And due to mutual force of attraction, they start to move. At some instant, A's speed is 2 and the speed of B is 4. What is the speed of the center of mass of the system? Very interesting question. Let's see how many of you can give this answer. Excellent. Come on, my warriors. Sir, when will Pandu and Champa come? Very soon, Vikram. Hold on. Dheeraj Rako. Yeah, just hold on. It will come. Okay, my minion says 0. Vishaka says B. Hello, L. Praveen Kumar. Welcome aboard, bacha. Welcome, welcome, welcome. Let's see how many of you can get it. Hello, Heyman. The Heyman saying 2. Roshi saying 0. Giddy saying 0. And the correct answer is 0. Perfecto. See, the answer is very simple. I'll tell you why. The logic behind this is particle A, this is particle B. Both of them were at rest. So what is the velocity of the center of mass? That is 0. Makes sense? Now, there is some mutual force of attraction, because of which what will happen after this was before, after this they start coming towards each other. Now, remember, this force is internal. If it's internal force, that means the momentum of the center of mass, which is the total momentum of the system, is conserved. And if it is conserved, that means the velocity of the center of mass must still remain as before, which is nothing but 0. Hence, the correct answer is option A. I hope this is clear. Kirtik, you can just lower the brightness on your end, bacha, because what will happen if I try to lower the brightness, then things will go haywire. All right, cool. Chalo. Hello Kela, hello, welcome aboard. Hello Mohammed, hello Jai Star, welcome, welcome, welcome. Great. Moving on to the next question coming up on your screen. A very important problem. It's also there in HC Varma. And let's see how many of you can get it. Hi Sabish, Narsimha. You can Start answering, and if you have any doubts, do let me know after the session is over. You can leave it in the comment section as well. Okay, a balloon of mass capital M is stationary. It has a ladder and there is a man, okay, of mass small m which is standing over here. And what is he doing? He starts climbing up with a speed of 2 meters per second. The question is, but that is relative to the balloon and the ladder. The question is, what would be the speed of the balloon? Think what will the balloon do? Think where will the balloon move? And this speed is given with respect to the balloon. This person climbs up with respect to the balloon with a speed of 2. Very good. Somebody has already done it. Okay, come on, my warriors. Chandan saying D, Harita saying D, Mohammed saying D, Maminin saying D. Welcome, Kirti. I hope you will enjoy the class. And in case you have missed the first part, I would request you to go back a little bit and start from the scratch, maybe even at a higher speed, so that you can reach wherever we are, just in case. Very good. Gokulnath is enjoying. Ojat saying D. I knew this. Many of you are going to make this mistake. So I'll tell you what. See, the balloon, when the person climbs up, will come down. So let's say the velocity of the balloon is V. So this is nothing but the velocity of the balloon. Okay. Now think about it. The person will end up moving higher. Okay, wherever the person is, he's climbing up. The balloon might go down. The balloon is very heavy. The balloon won't go so much. The person will climb up a lot. So think about it this way. The person climbs up 2 meters in 1 second. Okay, the person climbs up 2 meters in 1 second. But that is with respect to the balloon. What did the balloon do? The balloon, okay, has come down. The balloon has come down. How many meters? V meters in 1 second. I'll repeat. The person climbed up 2 meters in 1 second, but the balloon has come down by V meters in 1 second. So effectively, how much did the person go up by? How much did the person go up by? Think about it. Actually, he moved up only by 2 minus V meters per second is the velocity of the Pandu or that person, okay, with respect to the ground frame, with respect to the earth frame. Everybody agrees to this? Excellent, Harita. No, it's not 2 plus V, it's 2 minus V. Be careful. Yeah. So it's with respect to the balloon. So that's why you need to be very, very careful. Now, think about it. The velocity of the center of mass must be 0. And what is the reason for that? Because the center of mass must be at rest. Whose center of mass am I talking about? I'm talking about the balloon plus that Pandu plus that ladder, whatever that system is. So I'm talking about their center of mass. The center of mass stays there as it is. So person goes up, balloon goes down. So that's it. Use your standard equations. What will it be? What is the velocity of the center of mass? It will be mass of the person, okay? Or you can use momentum conservation. I mean, velocity of the center of mass is 0. That means the total momentum is also 0. So what is the momentum of the person or the Pandu? It will be mass of the Pandu into velocity of Pandu, which is 2 minus V. This is upwards. The velocity of the balloon is downwards. So I'll just put a minus sign there. Understand why am I putting minus sign? Because it's down. So mass of the balloon, ladder's mass, balloon's mass together is m into v. This whole thing will be 0. Think about this. This is momentum of the person. This is momentum of the balloon. Together, this should be 0. Everybody agrees with this? Think about it. Everybody clear about this? Excellent, my warriors. Now, just solve this question. So this will become 2m, correct? Minus, what is it? 2m minus mv minus capital MV is 0. What are you going to do? You're going to take both of them together on the other side. So 2m is equal to v is common, m plus capital M. Is that correct, my warriors? So therefore, what will v be equal to? It will be equal to 2m divided by small m plus capital M. So which is this answer? Oh, it is, I think, this option B. Many of you got it wrong. I hope that makes sense. Is that clear? So a lot of you made a mistake and told D. D will be the answer if this velocity was with respect to the ground. Then this actual velocity of the Pandu would not be 2 minus v, it would be 2. But this 2 was with respect to the balloon. That's why you need to be careful and use the previous concept of relative motion to solve the question. Yep, I hope this is clear. How did we get 0 on the RHS? Just because the center of mass is at rest. If the center of mass is at rest, that means the momentum of the system is 0. Hence, the momentum of the total momentum of the system must be 0. That's why I put 0. This is the sum of the momentums. I hope that makes sense, Jastar. Okay, chalo. Let's get moving. Amit, if you have any doubts regarding counseling, let me know after the session is over, or leave a comment after the session of counseling, below that. I will definitely respond to your counseling query. Okay, next question coming up on your screen. And here it is. Very good. Hello, Chitra. Thank you. Very good, Suchi. Solve it with me. Very good, Roshni. Excellent, Chandan. All right, Thandarskal. Let's solve the next question. There is an explosion and there are 3 pieces of the rock. One piece is 1 kg. Another piece is, I think, 2 kg. The 1 kg mass moves with 12. The 2 kg mass moves with 8, but perpendicular to each other. The third particle, I don't know how much the mass is, but I just know one thing, it moves with speed of 4 meters per second. So draw the diagram, think carefully how you can conserve momentum and what will be the equations, and you'll get the answer. Because that's the question, what's the mass of that particle? Okay, let's get going. Okay, very good, Jay. All right, no problem, Chitra. You can watch the replay even during the current session and catch up. Or if you are understanding it right now, then please continue, and maybe later on you can watch the replay. Okay, so here it is. We have a rock which is at rest. Okay, so this is a rock. I don't know how much is the mass, because I just know 1 kg, 2 kg and m kg. It blows up. Okay, one of the particle, which is 1 kg, goes with a speed of what is it? It's 12 meters per second. And another particle whose mass is 2 kg, it moves with a speed of how much? 8 meters per second. It is natural that the third mass, which will be m kg, will have to go this way with the speed of 4 meters per second. Look at that, that is 4 meters per second. Now, why would I say it will come this side? Think this way. This was the situation before. This is the situation after. The total momentum, okay, the total momentum of that system is 0. This is before, correct? Obviously, because there is no force from outside, all the explosive forces are internal forces, the total momentum should still remain 0. So one momentum is here, other momentum is there, the third momentum should be here. Because I know by vectors, one vector here, one vector here, third vector here will cancel out. So the total momentum of that system afterwards should also be 0. Fair enough? Everybody clear about this? Now, how do I find that out? It's very simple. This vector and this vector together will produce a resultant here. This vector momentum and this vector of momentum will produce a resultant here. That resultant will cancel this momentum which is on this side. Think about it. I'll just mention it over here. The resultant of 1 kg plus 2 kg, okay, whatever is the resultant, will be numerically equal to the momentum of that m kg, magnitude wise. Think about it. Why am I saying so? Because P1 plus P2, their vector resultant, if it cancels, that's the only way the total momentum will become 0. Correct. So let's find out the magnitude of P1 and P2. The magnitude of P1 and P2, remember they are perpendicular, so it will be root of P1 square plus P2 square, and this will be just equal to the Pm. I hope that makes sense because they are perpendicular. Pythagoras, P1 square plus P2 square. So what is P1 square and P2 square? It's mass into velocity, that is 1 multiplied by 12 square plus P2, which is 2 multiplied by 8 square, and momentum of mass m, that's mass into 4. Well, look at this. This is 144, 2 8s 16. This is 256, 256 plus 144. That's going to be nothing but 400. Root of 400 is going to be nothing but 20. Yeah, so 20 is equal to 4m. Therefore, m is equal to 5 kg. That's the answer. Where is it? Option D. Done, done. Let's see how many of you got it. Very good, Anil. I think you got it a long time back. Very good. Roshni. No, it was not 5. It was not D. It was 5 kg, which is option D. Very good, Chandan. Very good, Harita, Nishan. Excellent. Very good, Kirti. Very good. Okay. Chalo, let's get moving to the next question. So the idea was vector addition. First chapter of physics. Second idea, momentum conservation. Okay, before and after should be equal. So I understood these two's momentum will cancel this momentum. That's it. Rest is simple maths which you have learned. Next question. Very interesting question. Very good, Sasti. Let's see the next one. It looks lengthy, but trust me, it is one of the easiest one. Don't even look at the options. Okay, 5 spheres, 1, 2, 3, 4, 5 kg. They have speeds 6, 5, 4, 3, 2 respectively. 1 has 6, 2 has 5, 3 has 4, 4 has 3, 5 has 2. This is the speed for the respective mass. The first one collides to the second. They two stick together and they go ahead and hit the third one. They stick together. That collides with the next one. They stick together and finally collides with the fifth mass. And all of them move together. So, tuck, 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 they collide, get stuck to each other and they move as a one big chunk of mass. The question is, what is the final velocity of the total mass? Okay, let's see how many of you can do this. Okay, just to help you visualize. Okay, I have got some 5 balls. This is 1 kg, 2 kg, 3 kg, 4 kg and 5 kg. Trust me, it is very, very easy. Okay, let me just probably meanwhile mark it. Okay, I'm just hoping by the time I turn around somebody would have answered this question. Okay, 1 kg, 2 kg, then we have 3 kg, then we have 4 kg, and then we also have 5 kg. And this one has a speed of 6 meters per second. This has a speed of 5 meters per second. This has a speed of 4 meters per second. This has a speed of 3 meters per second. This has a speed of 2 meters per second. Okay, finally all of them stick together. Why are you worried about what happens in between? Just think before and afterwards, but after is like much after. Not when first sticks to second. 1, 2, 3, 4, 5. All of them stick together. They become one big mass. What's that big mass? 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, 15. 15 kg mass. And they move together with a new speed v. This is after. Okay, this is completely afterwards. And this was entirely before. So just use conservation of momentum. Conservation of momentum. You might be like, sir, they are colliding with each other. Remember, the force of collision is internal force. As a system as a whole, the force from outside is not there. All these forces of hitting each other, they are all internal, so you can conserve the momentum. Since collision force is internal, so I can use it, and let's see what do we get from this. Momentum initially, m into v, m into a, m into v, just add them up. So 1 into 6 plus 2 into 5 plus 3 into 4 plus 4 into 3 plus 5 into 2 is equal to 15 into v. Let's see how many of you can get this quickly. 6, and this is 10, this is 12, this is 12, this is 10 is equal to 15v. 12 plus 12, 24, 24 plus 6, 30, 30 plus 10, 40, 40 plus 10, 50. So this will become 50 is equal to 15v. Therefore, v is equal to 50 by 15. You can divide by 5. So you'll get 10 divided by 3 meters per second. How many of you got it? Woo! Very good, my minion. Excelente, Chandan, Harita. Very good, 3.33. Excelente. Excelente. Yes, it's a perfectly inelastic collision. But I have not even taught you inelastic collision, and that's the beauty of this. See, a lot of people learn inelastic elastic collisions first and then learn the how to apply conservation of momentum principle. Says even if you don't know whether it is elastic or inelastic collision, conservation of momentum is a universal principle. You can apply it for any colliding, exploding or any system where momentum is conserved, and that's the beauty of today's class. You will learn about elastic, inelastic and their specific properties, in the next class. So today we are talking only about conservation of momentum. Beautiful question. So 10/3 is the answer. Yep, that's option D. Interesting. Let's move to another question. This is also very interesting and tricky, and you might have seen this somewhere maybe, and you get scared the moment you look at springs. So what's happening over here? There is a block and it is moving with certain speed V0, and it hits a spring mass system. This capital M is 2m, where this is small m. This block first hits the spring compresses. The moment the spring compresses, it will push this block. So this block, the small m block, will slow down. Why? Because the spring will decelerate it. The moment the spring compresses, it will decelerate it. But because the spring is compressed, on the other side, it will push or it will accelerate the capital M block. So this one will decelerate, this one will accelerate. You will see the spring will get compressed and again it will come back. So it will get compressed as it is moving. So it won't stay at rest. Okay, as it is moving, it will compress and then it will again expand. So the question is, what is the maximum compression of the spring during this motion which is happening? Yeah, Shreyas already agrees with me that the springs are scary, but don't worry, it's not scary. I'll tell you how to visualize this. Okay, what is the spring exactly doing? Let's try to analyze the situation. The moment this small m block collides with the spring compresses, it takes away, it sucks that energy because it is retarding this small m. It sucks that energy and stores it inside the spring. And eventually, you will see that the spring will have maximum compression as both of them are moving. Before the spring again expands back again, because the spring is compressed, it does not like it, it will throw those blocks away again. So there comes a time when the spring is compressed by maximum amount before expanding again. Think what is so special about that situation when the spring has maximum compression. Come on my warriors, think about that situation when the spring has max compression. What is so special about it? Visualize it. When both the blocks have compressed the spring by a maximum amount, think about it, the spring is no longer contracting or no longer expanding. If the compression or the expansion is not changing, that means both the ends of the spring have no relative motion. Do you guys agree? Because the compression is maximum. That's it. At that instant, there is no relative motion between the ends of the spring. So this point is not moving relative to this point, and the other point is not moving relative to the other point. If there is no relative motion between the points, that means both the points are moving with the same velocity. They both are moving with the same velocity. There is no relative motion between them. Hence, I can say this one and this one have the same velocity v. Think about it. So at max compression, there is no relative motion between the ends of the spring. This is the concept which you should use for problems which involve maximum compression or maximum extension. Remember this always. Every time this will happen. Every time. Okay? Is that now clear? Let's move on. Achha. So let's see what we can do. Let's probably use energy conservation and see what we can get. So using energy conservation. Why is energy conserved? Because spring is a conservative force. There is no friction. So hence I can conserve the energy. This is before. This is after. What is the energy before? There is only one guy which is moving. This is at rest. So hence only kinetic energy of m. So it will be half m v0 square. This is before. Nothing else is moving. Remember, everything is at rest initially. Afterwards, There are two kinds of. Yes, there is tension in the string. The tension is the spring force. Correct. Hello Kalyani, good evening bacha. Welcome. I think you joined a little bit late. Join in. Okay. Now, here is the next thing. What will be the kinetic energy afterwards? This block also has, this block also has. Both of them have kinetic energy. So half mv square plus half, the other block is 2m. So 2m into v square plus one more term. The spring is compressed. How much is the compression? Let's assume it as x. So it will be nothing but half k x square. So all the kinetic energy has now got converted into the remaining kinetic and the stored potential energy. Very good. If you guys have understood it, let's move ahead. But there is a catch. You might have seen immediately, I do not know v. I want to find x. I know v naught, I know m, but I do not know the value of v. How do I find the value of v? Well, what did I just tell you? Use equations wherever needed. I think I have not used conservation of momentum itself. So, for this system, momentum is conserved. The momentum is conserved. You might be wondering, sir, what about the spring force? Think carefully. Spring is between these two blocks. So therefore, you can say spring is internal. Spring is internal force. So don't even bother about it. So what's the momentum before? It's only m into v naught. This guy is at rest. Is equal to. What's the momentum afterwards? Both the blocks are moving with the same speed. So m plus 2m, the whole thing into v. Correcto? Agreed? Let's move ahead. So from this I'll get v. This will become 3m. So this will become 3m into v. Therefore v will be equal to v naught divided by 3. What is the use of this? I can substitute this value of v over here and I can substitute it as v naught by 3. But before doing that, let me just do one small thing. I cancel this half everywhere and let's see what do we get. So mv naught square is equal to m v square. V square is v naught square by 9 plus you have 2m v naught square by 9 again plus kx square. So take these two guys over here. So you will have m v naught square 1 minus 1 by 9 minus 2 by 9 is equal to kx square. Okay, so what will you get? m v naught square. This is 1 plus 2 is 3. This is 3 by 9, which is 1 by 3. 1 minus 1 by 3 is 2 by 3. So I'm just going to write this as 2 by 3 is equal to kx square. So just move this around a little bit. I think you will get the value of x square. What is x square? 2m v naught square by 3k. Therefore, x will be equal to nothing but root of 2m by 3k. And that v naught, I can just shift it outside. So v naught is over here. That's the final answer. Very good. Okay, so the answer is v naught root 2m by 3k. Moving on to the next question. What is happening? There is a 3m mass, there is a string, there is a pulley, and on the other side there is a m mass which is hanging. From below, okay, there is another mass which comes and hits this mass. Hits, gets stuck to it, gets embedded in it. After that, what will happen? This system will move up. It will probably go till certain height and stop and come back. The question is, what's the maximum height? Interesting question. Okay, so when do we have to use that formula? You have to use the v square minus u square is equal to 2as formula only when acceleration is constant. In spring, force is variable, so acceleration is also variable, so you cannot use it in case of springs. Okay, so the logic in this question is, first visualize what is happening. This mass is lighter, this mass is heavier, so the string or the system will always try to go down like this. Lighter will try to go up, heavier will try to go down. But the heavier cannot go down further because there is a surface over here. So this surface will prevent the 3m from going down. So right now the system is at rest. Nothing is happening. The moment this block strikes this mass, what happens? Let's try to think about it. See, the moment, okay, let me just draw this as a system. This is my system, of course. You will see the string will immediately become slack. Why will the string become slack? Think about it. Because the moment the lower mass hits this, they together will move up. The moment the system m plus m tries to go up, the string is already taut, it's tight. The moment you decrease the distance, obviously the string will become loose, it will start hanging. Yep, correct, the string will become slack. So the new system will probably look something like this. I'll just draw this. Okay, this will be like that. This will be probably 3m. Okay, this is that surface. Okay, and the string is slack. So the slack string has no tension at all. And then here you have a 2m system which is now going up. That's what you will have. So this 2m block is going up. It will go up till certain height and it will come back. So this 2m block starts its journey, goes up and comes back. Basically what it is doing is a free fall motion, nothing else. It's just doing a free fall motion, and in order to calculate what's the height that it goes, all I need to know is what is the speed of the 2m mass when it just starts its motion. Remember projectile motion, 1D vertical free fall motion? You throw an object from below, it goes up, stops and comes back. So this is exactly like this. It's a free fall motion. With what speed does it start its journey? Okay, so that you can find the height. So it is v square by 2g. But be careful, this v is not u. That is the catch. Why is this speed not u? Because this v is the speed after the collision. This is the speed after the collision. So how do you find that speed? Using conservation of momentum principle. Let's use conservation of momentum principle to find this speed. Think about it. Why did it become 2m? Because there was a mass m which collides with this mass and it gets embedded in it. So embedded meaning m plus m will become 2m. That's why I've written 2m. Don't get confused over there, Ritika. Okay? Oops. Okay. Chalo, let's get moving to the next one. Okay, Satvik, good. You have completed the 12th standard and now you are able to understand. I'm so proud of you, bachalo. Okay, so here is the logic. Use conservation of momentum. What was the momentum before? This mass is at rest. This mass is moving. So it will be m into u. This is upwards. The other mass is at rest. The total mass is 2m. What speed does it have? V. So obviously v will be u by 2. mm gets cancelled. 2 comes below. It will become u by 2. So that's it. Use this formula. H is v square by 2g. That means it is u by 2 square by 2g. 2 square is 4. 4 into 2 is 8. So hence the answer is u square by 8g. So this is the maximum height that this block goes up after it gets struck from below with another mass m. That's the answer. Yep, correcto. Okay. Well. Dinesh, you should first complete 12th, bacha, but side by side complete 11th. If you just wait for completing 12th and then try to complete 11th, that will be disastrous. Please, on the parallel lines, try to complete 11th mechanics. This is what I would suggest, Dinesh. Okay. Moving on to the next question. But before that, let me tell you, if you guys have any doubts, you can use our Vedantu app, download it, take a screenshot or write whatever doubts you have and chat with our doubt experts. So you have doubt experts separately for chemistry, maths, physics, bio. You can ask unlimited doubts from morning till night and get all your doubts answered so that you don't have to actually depend on external websites and probably on some people who might give you the wrong answers. So make sure you make full use of the doubt app, and it's absolutely for free of cost for all the classic and the plus users. Alright, moving on to the next concept. Here we are again going to extend the conservation of momentum principle to center of mass, where you will have questions related to displacement instead of velocity. You might have heard about those questions. where there is a person walking on a boat or a plank, the person moves this much, another person moves this much, or there is a balloon, a person climbs 5 meters, how much does the balloon come down by, or a monkey balloon problem, or a block slides down something and this moves so much, how much will this move? These are the kind of questions that you will probably see in this section now. Idea over here is that, look at this pendulum which is attached to this frame. This frame can slide left and right very easily. Okay, it can slide left and right very easily. So this system will have some center of mass. Now when you release the pendulum, this bob of the pendulum will go here. But for this system, from outside there is no external force. For this system from outside there is no external force. That means the center of mass has no reason to move. Remember, only external forces can move the center of mass. So the center of mass of the system will not move left or right. So the moment the pendulum goes this side, this frame will go to the right. And the moment the pendulum goes here and again tries to come back over here, and the pendulum is coming back towards your right side, this frame will move towards the left. It will always try to preserve the center of mass wherever it is. Is that making sense? Yeah. So this is the principle, and you will also see it being applied for the boatman problem or monkey balloon problem or monkey man problem, whatever. Okay. So what happens is, you can see again for the person and the boat system, okay, the water has negligible force. Let's assume that. So the center of mass of the person and the boat should stay as it is. So if the person goes there, the boat goes behind to preserve the center of mass. So that is the preservation of center of mass principle. And whenever you get such questions, when center of mass is at rest, use my equation. You don't have to break your head. Lot of students use weird techniques. Center of mass is here, now it is here, now let's compare, random integration, derivatives, not at all needed. Yes, Chandan, it definitely reminds me of Prince of Persia. So the logic for solving these kind of questions is this. Whenever center of mass is at rest, use Shreyas sir's equation. And what is Shreyas sir's equation? m1 s1 plus m2 s2 plus m3 s3, whatever number of masses are there, add their products of mass and displacement, the total sum should be 0. As simple as that. So m1 is mass of first object, s1 is the mass of displacement of the first object, m2 mass of the second, displacement of the second, m3 mass of the third, s3 displacement of the third. Sum them up, the total product, the sum of the products will be 0. Keep this in mind. That's it. As simple as that. m1 s1 plus m2 s3 plus m2 s2 plus m3 s3 plus m4 s4 is going to be 0. Keep this in mind. And when is this true? It is only true when the center of mass is at rest. Let's solve some questions so that you get a hang of it. Okay, look at this question. Okay, so Kirtik, it will end by 8:50 or something like that, 8:45, around that, around 15-20 minutes or 25 minutes, yeah, more. A 3 kg rifle fires a 6-gram bullet. Okay, this is 3 kg rifle. It fires a 3-gram bullet at 500 meters per second. The question is, what is the ratio of the distance the rifle moves behind as compared to, the bullet moving forward in that time interval? Okay, what is the ratio of the distance traveled by the gun or the recoil of the gun versus the displacement of the bullet? I'll tell you, this is very simple. Use my equation. Well, I know, assuming that we are not holding it or something like that, or we are just talking about the barrel of it. So, you can see for this particular system, okay, for this particular system, if this is my system, okay, the center of mass is basically at rest. The bullet goes ahead, the barrel goes behind, and the barrel has a mass of 3 kg. Fair enough. Now, use the equation which I just told you, which is m1 s1 plus m2 s2 is 0. You can use this the moment center of mass is at rest. So let's use this. What is m1? The mass of the bullet is 6 gram. 6 gram is 6 into 10 to the power minus 3 kgs. S1, is the displacement of the bullet. Okay, let me put it over here. M2 is the mass of the rifle or that barrel which is going behind, and that is 3 kg. S2 is the displacement of that barrel, okay, barrel or that rifle. So this should be equal to 0. Shift it on the other side, and what will you get? 6 into 10 to the power minus 3 into displacement of the bullet is equal to minus 3 into displacement of that barrel. Now shift this bullet displacement below, and let's see what do we get. Displacement of the barrel divided by displacement of the bullet. This will give me 6 into 10 to the power minus 3, the whole thing divided by 3 over here with minus sign. So what will this answer be? Sure? Done? Okay, yes, very good. This is 2 divided by 1000, which is 1 by 500. Excellent. Very good. Oh, Ladia, you got a wrong answer. It is not none of these. I think you wrote D. Roshni, it is not D. Sorry. Okay, it is B. It is not D. Okay. Chalo. Moving on to the next question. Yep. Just have to use M1 S1 plus M2 S2 is equal to 0. Let's do one more question. Okay. And here it is. There is a wooden log of mass 120 kg and it is floating on still water perpendicular to the shore. Let's draw it so that we get some idea. Okay, so there is a log. Okay, there is a log and this is my shore. Okay, this is my shore and this log is floating some distance away from the shore. There is a man of mass 80 kg at the center of mass of the log. So this man, this Pandu, okay, this Pandu, he's standing here. What is Pandu's mass? It is 80 kg. And what is the log's mass? The log's mass is 120 kg. Interesting. Now what is Pandu doing? Pandu walks a distance of 10 meters towards the shore. Interesting. So if Pandu moves ahead, the log moves behind. This was before. So afterwards, what is going to happen is that the log will move behind and the Pandu will come over here. Okay, so Pandu is going to come here. Okay, probably I'll draw it even more accurately if you want. Okay, this is how it will probably look like. This is how it is. So the log has come behind, Pandu has gone ahead. So Pandu moves a distance of 10 meters towards the shore, obviously with respect to the log. Okay, and he stops. The question is, how far is Pandu now from the shore? You're like, sir, isn't it simple? Pandu was earlier 30 meters from the shore. It's given. Pandu was 30 meters from the shore. If he moves 10 meters, now he's obviously 20 meters away. Sir, option is A. Obviously that is wrong. Be careful about it. The reason is, Pandu did not move 10 meters with respect to the ground. He has moved 10 meters with respect to the log. Even the log has moved behind. So you do not know how much the log has moved behind. So be careful about it. So here is what we'll do. Let's assume the log's displacement, let's say, is S1. Pandu's displacement is S2. So using our principle, M1 S1 plus M2 S2 will be 0 since center of mass is at rest. Now if the center of mass is at rest and M1 S1 plus M2 S2 is 0, M1 is the mass of the log, which is 120. S1 is, I do not know, plus M2 is the mass of the Pandu. How much it is? It is 80 into S2 is 0. Now divided by 40, so you'll get 3S1 plus 2S2 is equal to 0. So from this I can find out what is S2, or I can find out S1. So S1 will be minus 2S2 by 3. This is crazy. I wanted to find S1 and S2, but I cannot find it out because I have one equation and two unknowns. This was one equation and we have two unknowns. So I think I need one more equation. So apart from Shreyas sir's equation, you need one more equation. And what could that be? Well, use this information carefully. He walks 10 meters towards the shore with respect to that log. So understand one thing very clearly, the displacement of Pandu with respect to the log is 10. This is given, hidden information, but it is there. Pandu's displacement, 2's displacement with respect to the log is 10 meters towards that side. That's all. So therefore S2 minus S1 is 10. Okay, so I think I can put S1 from here over there. So S2 minus, what is S1? S1 is minus 2 S2 divided by 3, correct? You can see it from here. This will be equal to 10. So just see what will you get next. Okay, what will you get next? Think about it. So minus minus plus, 3 plus 2, 5. So you'll get 5 S2 divided by 3 is equal to 10. 5 and 10 goes, so S2 divided by 3 is equal to 2. So S2 is equal to 6 meters. So the log has moved 6 meters behind. And if S2 is 6 meters, think about it. What? Oh, I have found it out. Oh, sorry, this is not the log, my bad. S2 is 6 meters. That means Pandu has actually moved 6 meters this way. That's it. I think now that will give you the answer. If this is 6 meters, how much will this much be? It will be 30 minus 6, which is 24 meter. That is the answer. Correct. Is that making sense? Is that making sense, my warriors? So the logic for solving these questions is that more often than not, only this equation may not give you the final answer. Most of the time, you'll have to use relative motion. And using relative motion, which Shreyas equation will then give you the final answer. That's how it is. Is that clear? Very good. No, Anirudh, why will KVPY be postponed? It is still on time. Don't spread false rumors and don't have false expectations. Okay, it's not going to be postponed. Don't worry about it. Great. Chalo, let's do one more very interesting question. This will blow your mind off for sure. Look at this. There is a block of certain mass m, and what it is doing, it slides down a ramp. Okay, this blue one is the ramp, starting from rest. Find the displacement of the block and the ramp just when the block reaches the bottom. That's the question. Okay, let's try to do this. Well, in this problem, if you take this as your system, you can clearly see that the net force in the x direction is 0. Can you see that? The net force, this block slides down, the forces are internal, all the surfaces are smooth, so there is no force in the x direction. But in the y direction, well, there is normal and gravity, so maybe net force is not 0. In fact, you will be like, sir, normal will be equal to mg, no? So if normal is mg, so net force will be 0, right? No, it will not be 0. Reason is, when this mass comes down, okay, center of mass is shifting down. It will not move left and right. Okay, so when this mass comes down, center of mass will come down. If center of mass is moving up or down, then normal will not be equal to mg. Think about it. Okay, it cannot cancel out in the y direction. So in the y direction, net force is not 0, but in the x direction, it is 0. That's the funny part about this problem. I'll repeat. As this block comes down, the center of mass will have to come down. Obviously, this block comes down, center of mass has to come down. If center of mass comes down, the net force in the y direction is obviously not 0. Because the only way center of mass can move or it can accelerate is when there is a force. Hence, there is force in the y direction. Okay, but in x, there is no motion. Okay, now let's talk about this. This mass, as it goes down, obviously this ramp would have moved behind, let's say by some distance. Okay, it has moved some distance, let's say I call it S1, and this block, okay, you can see right from here till here, it has moved some distance, let's say S2. Interesting. This is the displacement of the block. I can just probably mark it here as well. So this is the displacement S2 of the block. You might be wondering, sir, what am I comparing it with? Okay, I'm comparing it with the initial displacement, initial position. So this was where the block was according to x coordinate, remember, according to x coordinate. Okay, so this is how much it has moved from before. Why am I talking about the x coordinate suddenly? because the block is not only coming towards the right side, but it is also coming down. So there is motion in x and y axis. I am only interested right now in the x axis. So you can clearly see the x coordinate has changed. Here also this ramp has displaced towards the left side. Make sense, everybody, my warriors? Okay. Now, in x direction, okay, m1 s1 plus m2 s2 is 0. What is m1? The block's mass or the ramp's mass? It's the ramp's mass. So what is the ramp's mass? The ramp's mass is 3m. So m1 is 3m. s1 I do not know. m2 is m. s2 I do not know, is 0. Moving this around and cancelling m, so you will get 3s1 minus is equal to s2. This is one equation that I got. And makes sense. I mean, I will not be able to get both s1 and s2 just by one equation. I need one more. Just like the log problem which we just did before, you have to make use of relative motion. Without relative motion, you cannot eliminate both these variables. So let's use relative motion now. Think, how do you use relative motion? Sit on the ramp and just look at this block. You will see the block going like this. In x direction, you observe carefully what has happened. As this block goes down, the block has displaced towards the right with respect to that ramp. How much is the displacement of that block, which is number 2, with respect to the ramp? This is displacement of the block with respect to the ramp in x direction. Think about it. What is the displacement of the block with respect to the ramp? So that's what my minion, I'm just trying to explain that. Just think, you are sitting on the ramp. I know the ramp will move behind. Just for one moment, just imagine you are at rest. You just see the block going like this. You won't realize you are going behind. Just forget that you are going behind. You will see the block going like this. So actually the block was here. Now it has gone here. So how much did it move in x direction? Think about it. How much did the block move in x direction? Think about it. It has moved r distance. What is r? R is the radius. Think over here. This block from here till here, it has moved exactly r distance, which is the radius of this ramp, which is given over here. Makes sense, everybody, my warriors? Think carefully. So this will be r and this will be s2 minus s1. Well, this is just by definition. Now use the substitution which you have, or use the value of s2 which you have got over here in this equation. So minus 3s1 minus s1 is equal to r. So s1 4 times is equal to minus r. So s1 is equal to minus r by 4. So what is this s1? S1 is nothing but the displacement of the ramp. And what is this minus sign denoting? This minus sign denotes that it is towards the left side. You don't even have to, bother about which side it is moving. Automatically the answer comes out to be positive or negative. It makes sense. It has gone towards the left. Now make use of this equation and see what is the value of S2. So S2 will be, think about it, since I know the value of S1, so minus 3 times of S1. S1 is minus R by 4. So which is 3R by 4. So immediately many students are going to be like, sir, I got the answer. S2, displacement of the block is 3R by 4. And that's where you made the mistake. That is not the final answer. You're like, sir, what nonsense. I just got S1. That is what we wanted to, we just got S2. That is what we wanted, the displacement of the block. No, that's not the final answer. Like, why? Because S2 is only the displacement in the X direction. It has also moved in the Y direction. Yep, it is moved in the Y direction. So do not forget that. So strictly speaking, what you have found out is earlier the block was here. Earlier the block was here. It moved this much in X, but it has also moved down by R. Do you see that? It has moved down by R. Hence, the total displacement the total displacement is this square plus this square. That's the catch. So the displacement of the block will be root of this square, which is 3r by 4 whole square, plus this square, which is r square. R comes outside the root, and 3 square is nothing but 9, 4 square is 16 plus 1. So 9 plus 16, 25 divided by 16. So 25's root is 5. So I can just write it as 5r by 4. So that's the displacement of the block. Very interesting. 5r by 4. Hello Narbabi. Excellent Kirti. Very good. So I hope Divya now you understood it. Yeah, it is slightly confusing, but it is very good. Oh, J, D, J, UD. What names, man? Why do you have such tongue twister names? Okay, glad you saw that, and that's all about parallax and yeah, relative motion. Very good. So very interesting question based on two-dimensional motion, where you have direct application of center of mass. You also have application of relative motion, and you also have to make use of vectors because 2D motion. Yeah, very good. So now I have 3 questions for you as homework. Yeah, that's the answer, by the way. So this is a first homework question. Okay, put up the answers in the comment section. This is your second homework question, and this is your third homework question, and the answers for this along with the solution will come up on the Telegram channel. Now let's also see who and all have answered last time. So very interesting to know this. Okay, there we go. There we started our class, impulse, momentum, variable mass. Yeah, that's what we did in the last class. Wow, we have a lot of people answering it. Very good, Suji Mama. Very good. I think I forgot to like this. Very good motivation for students. Ishpreet, Kane, Molesh. Thank you, Strasti. Very good, Chandan. Okay, just Chandan is very happy. And Aditya, very good, Bacha. And Harita, thank you. Thank you, Gokulnath, for those lovely comments. And very good, Saja. And I think KSK Ritika had some doubt. I answered it. And even Muhammad Samin had some doubt. And Gokulnath, thank you so much for your sweet comments, Bacha. Okay, so Vimla, from the basics, well, we have already taught it from the basics, and I'll tell you how you can go through the first lecture of mine. All you need to do is go to playlists, and when you go to playlist, Bacha, you are going to find all the chapters which I have taught before this. So if you go and click on JEE Physics, you will see vectors, units and dimensions. Everything from basics has been taught already. Okay, now one more thing that you need to know, that when you're watching this class, is that if you go below, you have all the options to join Vedantu Pro subscription, be it CBSE Term 1, Term 2, be it CBSE Term 1 crash course, or if you want the full term course, then go for JEE 2 years course. In that, you not only get the long term batches, but you also get the short courses. Like let's say suddenly CBSE exam comes up, so you will get the CBSE course for free of cost. KVPY, it's free of cost, so you don't have to pay separately. Else you'll have to join these courses separately. So this Pro includes all the revision, other courses, topic specific courses with test series, analysis, assignments, notes, doubt solving. After the class, if you want doubt solving, you go for the classic version, and when you want personal guide, you want one-to-one attention, then you go for the plus version. I would suggest at least try the light version. Most of the students are going for classic version. Very few students who need that personal attention go for the plus version as well. So try out the light version, and here it says 15 days, but the best part is on 15 days you get 15 days more free. So you are getting 1 month course for 15-day price. That's the offer running right now. So earlier the prices were around 2,000 or 3,000 rupees. Now for 1,350 rupees you are getting, the course for 1 month. So try it out for 15 days. Click on this, and you have to use my coupon code, which would be already applied, which is SSHPRO, and you get 10% off. So that's the best part about this. So I hope to see all of you in the Pro subscription. Make full use of this 15-day trial period offer, where you get 15 days plus 15 days free. And the batches are going to be in English, so that's a plus point, and you can watch the recordings at any point of time. Very good. Oh, you are already my Pro Plus student. Very good. Okay, is collision between an object and a spring always elastic? Ritika, yes, it will be. if it is an ideal spring and there is no loss of energy given in the question. So unless and until it is specified otherwise, we will assume it as an elastic collision. Okay. Rajiv, no, this is not the fourth lecture. This is the second lecture of this chapter. Center of mass is considered as a separate chapter. Okay. And momentum collisions is a separate chapter. But depends from book to book. So according to NCERT, it could be different. According to H.C. Verma, according to Cengage, according to any other book, it could be different number wise. Bye bye Harita, take care. So what is the meaning of Asli Vista? Asli Vista, nahi, Hasta la vista. Oh, that just means bye bye. Yeah, that's just a fancy way of saying bye bye. Yeah. What is tomorrow's topic? So tomorrow we are going to complete this chapter. Tomorrow we are going to do inelastic collisions. We are going to find out energy. We are going to do oblique collisions, collisions in 2D. All these things will be completing tomorrow at 7:30. And yes, you're going to have a KVPY SA mock test on Wednesday. So be there. Make sure you hit the subscribe button and also hit the like button so that YouTube will recommend my videos to all of you and you do not miss any of the classes then. Yep. Tomorrow also you have class at 7:30. Bye bye. Take care, my warriors. Have a great time. Hasta la vista.